Just like to say before we begin is that this is not meant to be a professionally made video. I've created it using my mobile phone, and its purpose is to demonstrate why it is necessary to use correction factors when testing Powersonic batteries with an ACT meter. First of all, I'd like to emphasize that there is no way other than to do the time-honored discharge test to measure the true amp hour capacity of a battery. The static laboratory testers that are designed to test for amp hour capacity is the Bytrode LCN 1250. These are the blue testers that you can see right there, and these circuits will test batteries up to 1000 amp hours. Then there's the Cadex C7000, which is also a very accurate piece of testing equipment and is designed for laboratory testing of smaller SLA batteries up to 40 amp hours. This is the tester generally used for testing our fire and security batteries. Okay, the next step is to check the state of charge of the 17 amp hour battery, and we'll do that using a good quality multimeter. So the open circuit voltage there is 13.09, and that confirms that the battery is fully charged. Okay, next we're going to do a test on the battery using an ACT Gold Plus tester. Okay, it's important that you get a good connection onto the terminals. It's going through analysing battery phase, set to calibration, so that it's set at 0 at the moment. It's testing volt, so it's testing the battery, a very light load on the battery. And then we press red button to start the test. There you have it. So it's come up with a 14 amp hour reading, and so that's obviously drastically failed our battery, failed the Powersonic 12 volt 17 amp hour battery. So we're getting 14 amp hours for a 17 amp hour battery. Okay, next we're going to do a battery test using the latest ACT battery tester. Again, making sure we get good connections on the battery terminals. Okay, it's powering up at the moment. Set to calibration, down at 0. That's the voltage, on-load voltage. Press to start. There you go, there you have it again. We're getting a reading of 14 amp hours on a 17 amp hour battery. Again, it's failed our battery. I mean, that is roughly 30% lower than the actual capacity. There is an alternative tester on the market. It's called the Midtronics SEP6-12. This tester measures conductance of a battery, and by inputting a reference conductance value of a good known battery, the tester will compare that value with the conductance of the battery under test. The result is then displayed as a percentage. So for a PS12 170 for a 17 amp hour battery, the reference conductance value is 400. So by inputting that number, we can go ahead and test the battery. Again, making sure get good connections onto the terminals. It's a 12 volt battery, so it's been set at 12. Next thing, we've got to input the reference value. The reference value is 400, so we'll just check that first. Okay, it's already set at 400. So all we need to do next is just press S again and it'll start the test. So the conductance, the percentage conductance is 119%, which indicates that the battery is good quality. It hasn't reached its end of life, and it's not defective. Okay, the Midtronics test has indicated a relative conductance value of 119%, which indicates that the battery isn't defective and it hasn't reached the end of its service life. The battery therefore doesn't need replacing. So a reading of less than 60% is indicative of a battery that has reached the end of its useful service life. You can see therefore the Midtronics test is a far more superior tester, and provided you have the appropriate reference values, which are available from the battery manufacturer or the Midtronics website, any brand of battery can be tested.